So we've just collected the integer arithmetic quiz, and what I'm going to do with that is look at the problems that you said this is the right answer and find out whether or not you made a consistent mistake or whether or not you did that. Now, one of the interesting things about high school and college is that you have this thing that's called a calculator. And so if your math is fuzzy, or if you're tired and you can't think, the calculator is part of your tools. And so I did not want you to use a calculator to do this work because I wanted to see how much came from you, right? I was telling Aria that I started tutoring 2 years ago with 5 boys in 3rd, 4th, and 5th grades that did not know their math facts. So I started tutoring multiplication facts and adding facts, right? And those students were destined to fail math for the rest of their school life because they didn't have the facts down. What's nice is when you get into high school and into college, you're allowed to use the calculator because in most cases, the calculator can't get you the answer. The calculator can help you with the arithmetic, but not the answer, right? And one of the things that I would recommend is if you have a calculator, that you get one that has a display of what you punched in and the answer separate. Right, there's a group of calculators that if you put in 4 times 5 and press the enter button, it just gives you the 20. And it doesn't show you the 4 times 5 on the top line. And so if you made a mistake, didn't include a negative or whatever you were supposed to do, you can't see what you punched in, and so you're going blind on whether or not 20 is the right number to use for the next step, if that makes sense. Mm-hmm. So if you have a calculator, and you can get a TI-30A for about $18, which will be usable on any standardized test because there's only a minimum amount of storage memory in it, and you can't store equations that you're supposed to know and things like that. So that would be something that you would want to start upgrading to. And like I said, the TI-30A with the displays which you're looking at, and they're less than $20. And you can get them at any drugstore or Walmart or anything like that. So that would be something I would recommend, especially because you'll see on the package that it is usable on SAT and ACT and standardized tests. This calculator, which is a graphing calculator, cannot be used on those tests because you can hide information, you can store information and hide it, and so it's not usable on those tests, but the other calculator is. So, okay, anyway, so what I'll do is I'm going to look at these and look for strengths and weaknesses. I found one today when I was working with someone, and that person did not read a negative sign, excuse me, a subtraction sign as a negative. And so if you look at this particular problem here, problem A, it says negative 62 plus negative 25. That's 2 negatives added together, and so the answer is going to be negative 87. All right, that one you should have gotten. The subtraction problem right here, this is a 44 and a negative 16 added together because of the definition of subtraction says that this is 44 plus negative 16. And so if you pick this subtract sign up as if it were a negative with the 16, you're going to have 44 and negative 16, so you're going to subtract. All right, and the answer is going to be 28? Positive 28. Now, another thing for mental purposes of integers. All right, you worked with a number line going like this. We used to teach number line going up and down. Okay, now watch this. Okay, this is 0. Where is negative 6? it's down here. What happens if I subtract 5? I'm going to go deeper. So I'm going to have negative 11. Right? If I'm here and I'm at negative 6 and I add 10, I'm going to end up above 0. And I'll be at positive 4. And so sometimes if you think of the 0 like a thermometer, and the positive of the thermometer is here, the negative of the thermometer, then when you're adding or subtracting in your head, which we do a lot of, but not with big numbers. But when you're using algebra, you're going to use the coefficients and you're going to add or subtract them. So if you think of 0 here, negatives here, if you subtract the negative, it's going to get deeper. It's like stacking them up. Okay, so that's another trick that may help. Okay, all right. So that takes care of this. All right. I didn't get any questions about section 1 on sets of numbers. All right. Nobody emailed anything, so I'm assuming that most of you got those correct. So I'm going to just do a quick review. It's not that one. We're good. There it is. Okay. Now, I gave this as a handout, I believe, last time, right? Or I had you write it down. All right, now, why is this important? All right, Forrester is going to be changing the domain of certain problems. Now, the domain are the values that x can assume to start. All right, whenever you have two variables, one of them has to be the dominant or the starting one, and that's usually the horizontal line, right? And the other is the dependent, and it depends on what you started with, where you end up, right? So the one becomes independent, and the other becomes dependent. The x is usually the independent one, all right? And so what he's going to do is he's going to change the types of numbers that x can be. So and that's called the domain, and we'll get into that if you forgot that. And so these types, so if it's digits, if x can be a digit only, then you only have 10 choices, 0 through 9, right? If x is all natural numbers, then you can't have a 0. You start with 1 and use the whole numbers from 1 on infinitely large. All right? Now, the difference between a whole number and a natural or a counting number is the whole number has 0. Okay, why did they find it necessary to have whole numbers? Anybody know? All right, for subtraction. If you have 30 cows and you sell all 30 cows, how many do you have after you've sold the cows? 0. There didn't used to be 0 as a number. Because if you counted the number of cows, you don't, like if I'm counting the students here, I don't start 0, 1, 2, 3, 4, 5, right? We start with the first one. That's a natural or accounting way to do numbers, right? But when subtraction came on, they had to end up with a 0. And so somewhere around 600 BC, there were two systems that developed 0 completely independent of each other for the reason of subtraction. All right? Now, then what is an integer? An integer is what? It's a positive or negative whole number. Right? It's a positive or negative number. And why is that needed? It's needed for theory. Right? Negative is weird. Right? That's why it's not introduced in the lower grades, or shouldn't be, because it's an abstract concept, and until students get to the age of 8 or 9, they are so concrete in their thinking that it's really confusing to try to explain what negative is. Now, we have some good ideas. The number line is a visual way to explain what negative is, but negative doesn't make any sense, especially to a young kid. So these are things. Now, I said last time, and this is important, repeating and terminating decimals. Are they rational or irrational? they're both rational. All right? In 8th grade, we used to have a whole lesson on how you find the rational representation of a repeating decimal. All right, now, get your calculators out. Let me show you this. All right? All right. You can try this on the video. You can try this a little bit later. Take 2 and divide it by 9. What do you get? 0.22222 on and going, right? So 2 9ths is the decimal 2 repeating. Okay. What about 3 9ths? 3 divided by 9 is 0.3333. All right. What about 7 divided by 9? 0.77777, right? So if you have a fraction that has a 9 as a denominator, you're going to get a repeating decimal that is either going to be 1, 2, 3, 4, 5, 6, or 7, 8, repeating depending on what the number was. Okay? However, can anybody tell me what 3 9ths is again? What's 3 9ths? 0.333, but don't we know that is a different fraction? 1/3 is 3 9ths. So whenever you see a display on your calculator that is 0.33333 repeating, you know that that is 1/3 or 3 9ths. And so you should be able to interpret off your calculator whenever you see that display. Now, what about 6 9ths? 6 9ths is going to be 0.6666666, all right? However, because the calculator rounds, the last number will round to a 7. Not because it changes to 7, but because the calculator is programmed to round it. So when you see 0.66666, right, as far as the displays are, and then a 7 at the end, you know that that is 2/3 because it was 6 9ths. Okay? Now, that should allow you some help in changing the display on your calculator to a fraction if you have to report it as a fraction. All right, that makes sense? Now, I have seen too many students that don't know what to do when they see the repeating decimal. All right, that's one of the things that happens. All right, okay, does that help? Now, what happens if it terminates? All right, if it terminates, it's going to be in the tens. All right, so what is 0.4 as a fraction? 0.4 is 4/10. Simplify it. 4/10 is the same as 2/5. Okay. All right. And those are things that happen. Okay. So all repeating and terminating decimals are rational, and they can be represented by 2 integers, positive or negative. Now, a rational number is supposed to be simplified. All right. That's now. What do I mean by that? It means that you take out the factors that are common. Right? You see whether or not they're both in the 2 times tables, both in the 3 times tables. You can skip 4s because you find that in the 2s, both in the 5s, both in the 7s. All right? If that's possible, then you take those factors out. Now, in high school, you do not have to change an improper fraction to a mixed number. Okay, why? Because most of the time, if you need an answer, you'll throw it in the calculator. Okay, so what happens if you have 15 sevenths? All right, what is 15 sevenths? Now, I could change this. 7 goes into 15 2 times with 1 left over, so that equals 2 1/7. If I wanted to make a mixed number, but what happens when you throw it in the calculator? Go ahead, do it. Put 15 divided by 7 in a calculator. 2.14. So that equals 2.14. What's the next number?
2.
2. All right, now, what's interesting about sevens is 7 is a repeating decimal. 5 digits repeat. And it's strange, and it's fun. If we had a class, again, if we had a class on repeating decimals, we would go to the 7s after we did the 9s. All right, and so that's it. But again, normally we would want something to the thousands place. All right, and so this 2 becomes a 3, I think. This is followed by an 8. Right, and so we would look at 2.143 as an estimation of this repeating decimal, right? And so that's the other thing. And I said this last time. If I were to ask you to write completely the digits for pi, right, you would die. That would be a death sentence, right? To write it completely, because pi is a non-repeating, non-terminating decimal. All right, and so it goes on infinitely long. And I think that they have calculators that have taken the estimation for pi to something like 1 million characters through a computer and not found a repeating pattern. People have done it into the thousands by hand and not found a repeating pattern. So that's why it becomes, what does he use the term? Transcendental. It becomes a transcendental number. It's a number that makes sense. Now, speaking of pi, where did pi come from? What is it a representation of? It's a representation of the ratio of the circumference of a circle to its diameter. Yes. Right? Okay, and what is that ratio? 3. Right? So if the radius is 7, what's the approximate circumference? 7 times 3. 21. Now, it turns out that 3 is not exact, but boy, it's a pretty good start, isn't it? Yeah. Okay, and then depending on what I like to tell my best students is that pi is 3.1416, not 3.14, because if you use 3.14, then you're only good to 1 decimal place. Yeah. Right? Use 3.1416, you're good to 3 decimal places. Okay. All right. Okay, so that takes care of that, and that irrational numbers. Irrationals are roots that are not perfect. So it's square roots that are not perfect squares. It's cube roots that are not perfect cubes. All right, and again, they are non-terminating, so they're continuous, non-repeating decimals. And so what happens when we have these? We have to estimate. How many places? If you use 3 places, you're always good for money, right? Because how many decimal places is there in dollars and cents? 2, right? So if you get used to using 3 decimal places, then no matter how they ask you to report your answer, you'll have a very good precision. If you only use 1 or 2, then you don't have as much precision. But if you use 3, then almost everything you're going to be asked to do, you'll have the correct precision. That means how accurate you are. Okay? All right, so that takes care of those. And now we're going to look at what happens this week. Now, for this week, your assignment is going to be algebraic expressions in 1.3 and polynomial vocabulary in 1.4. Okay? Again, this for somebody that got a B or an A in Algebra 1, this is still review work. It's not that tricky, right? But it is something just to get you started. So we're going to talk about some of these, and I'm going to go over these one at a time. All right, first of all, absolute value. There were some absolute value problems on your little arithmetic sheet. Absolute value is always what?
Positive.
Positive. Say that.
Positive.
It's always positive. What's always positive?
Great value.
Absolute value is always positive, right? So it doesn't matter whether or not what's in there is positive or negative. when you come out of the absolute value marks, you have to use the positive. So can absolute value ever be negative?
Yes.
Well, very good. Well, maybe, right? Okay. In order to have absolute value negative, you have to have a negative sign on the outside of the absolute value. Right? So if this is 3 minus 7, all right, what's inside the absolute value marks?
4.
Oh no. Negative 4.
But then
This is negative 4. The absolute value marks makes it positive 4, and this sign makes it negative 4. All right? Now, okay, so now there are some that, because absolute value is supposed to be positive, they forget that we can make it. Now, the same thing is true square root. What's the square root of 16?
4.
4. It's actually positive 4 or negative 4. Right?
Right.
Because negative 4 times negative 4 is
Positive
16. Right? So, what happens by convention, by agreement, this will represent the positive root, and this will represent the negative root.
Yeah.
Right? But technically, they're both is positive or negative 4. Right? But by convention, we always consider this to be the positive root. Just like the absolute value is positive, and so to be able to get it to be negative, I put a negative sign on the outside.
Right.
All right? Okay, so that's, again, that's review, but important to remember. Okay, now, all right. Order of operations. Okay. This is the correct method, according to Mr. Belcher, for writing an order of operations table. And some of you may remember, please excuse my dear Aunt Sally. Okay? The problem with this is it is not 6 things. It's 3 things. There are 3 different priorities. There's parentheses and exponents, please excuse. There's multiplying or dividing, right, my dear, and then there's adding or subtracting, Aunt Sally. And if there's a tie, you break the tie right to left. Actually, that's backwards. Oh no. It's supposed to be from left to right.
Yeah.
Okay, so I have to change that sign. I'm glad I didn't print that
It
out.
says left to right on yours.
Yes, I know it. I know it.
You were half.
Well, I'm old. Okay.
Don't worry, so.
See if I can
Left to right.
move it. All right.
Please.
Okay. Now, so you break the tie from left to right. That makes the order of operations important. And what I like to see done, if you have order of operations that are complicated, is that deal with the parentheses and exponents and rewrite the problem underneath it. Simplifying, and most of that simplifying is math you can do in your head, right? But simplify it, and then do a second simplification with the multiplying or dividing, right? And so you'll copy a term that's added but not multiplied or divided, right? And then so you have a second line, and then what you'll have left is just adding and subtracting, which if you have to, you can put in the calculator. Now, why don't we see very much order of operations in high school work? Good question, because it's tricky, isn't it? All right, the calculators are programmed for order of operations. So if you have a calculator that has parentheses and you put in the order of operation problem exactly like it was, the calculator will come up with the answer. And that's another reason why I didn't want you to use the calculator when you were doing this arithmetic assignment. Okay, so is that helpful? Yes, yes. Okay, and so we know that the order of operations, our calculator is going to help us get the right answer. Okay, so this is the way it's supposed to be. When I taught this in grade school, one of the biggest problems I had was kids that did all the multiplying before they did any dividing. All right, now that's a concept issue. All right, and the concept issue came from the fact that the 5th grade teacher didn't tell them that it was 3 things, and so the student assumed that it was 6 things. And they did all the parentheses and all the exponents, and normally those were separate into individuals anyway, so you would normally do those one at a time. Right? And so when they got to the multiplying and the dividing, they thought that their rule stuck, and so they did all the multiplying, and then they went back and did all the dividing. So how do you catch that? 12 divided by 2 times 3. All right? Anybody that has that error is going to go to the times first and say 2 times 3 is 6, 12 divided by 6 is 2. Right? So through analysis, I can find the person that made that false assumption with one problem. Right? That's why it's on that paper. Because you need to understand, now, I'm hoping that all of you do understand that. Yes. But it's possible through getting every answer right with order of operation that you made the wrong assumption, but just never got it caught, never got it exposed. All right? So that's what that is. Okay, now, next thing, this is a little bit newer. Why won't this work? Not there. All right, polynomial vocabulary. There are 2 sets here. These are the vocabulary words from the chapter. I got 2 Y's on polynomial, so I need to change that. Alright, so monomial, binomial, trinomial, polynomial. Alright, what's mono? Mono, uno, mono, 1. Bi, 2, tri, 3. Okay, so if you look at it, if there are terms. Now, one of the things I didn't see here, because it's part of Algebra 1, terms are things that are added or subtracted. So if you didn't know that, you need to write that in your notes. Right. Terms, things that are added or subtracted. Okay, so here's my question. Assuming that is the end right here, this 9, how many terms are in the polynomial that I'm pointing at?
3.
There are 3 things being added or subtracted. Each of those things is a monomial. All right? The 7x to the 4th is a monomial of degree 4.
Right.
All right? Now, technically, it's called a quartic or quartic. Right? So you have linear for x to the 1st, quadratic for x to the 2nd. We've done quadratic equations. Then cubic, quartic, quintic, and everything above 5 will be a blank degree. So 6th degree, 8th degree. All right, now, the degrees are based on the number of the exponent sum. The number of the exponent sum. Because almost all of the polynomials that you use have one variable at a time, then everybody assumes that it is the one exponent that gives you the degree. But if you had 2 variables in the same monomial, for instance, x to the 3rd, y to the 2nd, what degree is that?
5.
Degree 5. This 3 plus this 2 is degree 5. Now, so the monomial degree is the degree of the sum of the exponents. Okay? So, suppose I gave you w to the 5th x. what degree is this monomial? I tricked you. 6. Why? Because there's a 1 there that's in stealth mode.
Yes.
All right? So that's degree 6. Okay? And again, those are the tricks that in a problem, right? If they're talking about degrees, they'll throw one of these in, hoping that you'll just look across and just all the exponents that you see, you add up. Right? Okay, so if you know that the exponents that you see you have to add, you are a good algebra student. The best algebra students don't need the 1 there to know it's supposed to be there. Right? And so that problem is one that separates good students from the best students. Okay? And so knowing that going in, you got to be careful. And the same thing is true with 1 as a coefficient. Okay? How do you write 1x? All right, now, a literal writing of 1x would be this. All right? But what is this? That's 1x, right? Because how many x's are here? 1, right? And so, what you have is this. Now, does anybody recognize that property? That's the identity property of multiplication. Right? And so because of this, the 1 could be in stealth mode, or if I got it this way and I didn't want to get confused, I could throw the 1 in without changing the problem. So it's used a lot in working through algebra, but it's not necessary in simplest form. Okay? And the same thing is true with the exponent of 1. In simplest form, the exponent of 1 is not necessary. So when you turn your work in as a final answer, it's supposed to be in simplest form. So this 1 will not be there, neither will the 1 be for the exponent, if it's a single exponent. All right, makes sense? Okay, so monomial, binomial, trinomial, 1, 2, 3, and everything above that would be a blank term, polynomial. Okay, now, the next part deals with the degree. All right, this is an important one. If the exponent on the variable is 0, what's the number? What's the value? Oh, that's cool. All right, that's something that you need to know. All right, everybody write x to the 0 power.
Oh, okay. I got you. Well, it has to be 0, right?
X to the 0 power does not equal 0. X to the 0 power equals 1.
Because it's 1x.
Because it's 1.
Oh my gosh.
No, the number 1.
Right.
Okay? So, watch this. Is the same as x to the 0 over x to the 4th. And if you remember from your exponents, whenever you divide, you subtract. So what is 0 subtract 4? All right, so you know that 1 over x to the 4th is the same as x to the negative 4 power. All right? This is very important. It's used a lot in analyzing algebra. So any number, so again, what would I test you on? If we were testing, I would say 15 to the 0 power equals. What's the answer? No. No, that didn't get applied. 15 to the 0 power equals 1. Any number to the 0 power is 1. What is 23 to the 0 power? 1. What is x to the 0 power? 1. All right? Again, it's an abstract term, but it's important. Okay, now, here's the other trick. What is 15 to the 1st power? 15. What is 1 to the 15th power? 1. Because it's 1 times 1 times 1 times 1. Okay? So, all right. Okay, so as far as if we were in an Algebra 1 class, those are the problems that I would want you to be able to understand.
Right.
Okay, and so we're going back in review. Now, from that, therefore, a 0 power is a constant. Why? Because it leaves the number 1, or it leaves whatever is left as the coefficient. Right? So if my variable is y, then 14 is the same as 14y to the 0 power. But 14 is a constant. Right?
Yes.
So that's what you end up with in simplified form. You're going to end up with a positive or a negative value. It could be a fraction. But it's the number that doesn't change, and so that's why it's called a constant. Okay? Now, linear has a power of 1. Now, as we get into conic sections a little bit later, don't worry about that name, we'll get that later. But when we get into conic sections, you're going to be looking at the exponent on the variable. And the exponent on the variable is going to tell you something about what the graph looks like. So understanding that first power is linear, and you did that in Algebra 1. You worked on lines, right? And where the lines cross the y-axis, which goes the y-intercept, you worked with slope. All of those things will be reviewed, but that's all linear. And when you get to quadratics, which is x squared, and all of the FOILing that you did, the multiplying of two binomials, right? That all is quadratic, right? And this is where I put x first, y first is degree 2. Okay? Because 1 plus 1 is 2. Okay? Now, cubic is 3, quartic is 4, quintic is 5, and everything above that would be a blank degree. All right, now this is all vocabulary. Does it help you solve a problem? Not really, but it's vocabulary. So if I'm trying to communicate with you about what kind of polynomial you have, those words will help describe what you're going to be looking at. Yeah, so that's the main part of those. Okay, now. What time do we stop? Oh, I know.
Whatever time the next class. I know we finished 5 minutes before the next class starts.
Yes.
That's all I know.
So here, look at that. We're going to go to 10:25.
15 minutes.
So we got 15 minutes. We did good. We did good. All right. Now, all right. Any questions so far? I should have stopped before that. But any questions?
No.
No?
Okay.
2 hours wait for me.
All right. Okay, let's do this. I think this is a good place to stop if we don't have any questions. All right, I'm going to go back over what you're going to be doing. Is you're going to be doing sections 1-3 and 1-4. The quick questions 1 through 10, and then you're going basically 2 to 36 and 2 to 34. All right, now. These, again, they're relatively easy problems compared to high school calculus, right? But there are some tricky problems involved. If you don't get the right answer, then go to the odd number before it, right? And if you'll notice in the Forster book, the odd number and even number are side by side. Right, all the odd number answers are in the back of the book.
Yes.
All right, if you have a struggling problem with the even number, you go to the other side of the page and use the number that's 1 less. That does the same work. Okay? All right. And you have about 10 minutes to get started on your homework assignment. So if you want to start reading through section 1-3, you may. All right. I don't know how to stop this.
Students waiting.